Operations on integers. We have learnt about integers and absolute integers. Now we shall learn about the fundamental operations on integers. The following are the mathematical operations that can be performed on integers: addition of integers, subtraction of integers, multiplication of integers, division of integers. Addition of integers. Tanuj has 10 mangoes and his mother gives him another 15 mangoes. He needs to know the number of mangoes he has now. Let us help Tanuj to calculate the number of mangoes he has. Tanuj has plus 10 plus 15 equal to 25 mangoes. Altogether, Tanuj has 25 mangoes. From this, we learn that the sum of two positive integers is a positive integer. Sumukh had lent 5 rupees to Sahil and 12 rupees to Sudeep. He is worried and wants to know how much he has lent. Sumukh has lent 17 rupees. He now has 17 rupees less with him. This tells us that the sum of two negative integers is a negative integer. Meera had 50 rupees. She gave 15 to her sister. Shall we help her to calculate the amount she has? Plus 50 plus minus 15 is equal to plus 35. After giving 15 rupees to her sister, Meera has another 35 rupees left with her. Properties of addition of integers. The sum of two integers is an integer. For example, plus 40 plus minus 15 is equal to 25. Minus 7 plus minus 8 is equal to minus 15. For all integers a and b, a plus b is equal to b plus a. For example, plus 20 plus minus 7 is equal to 13. Minus 7 plus 20 is equal to 13. Hence, plus 20 plus minus 7 is equal to minus 7 plus 20. Try out with some more integers. In each case, you will find a plus b is equal to b plus a, where a and b are integers. For all integers a, b and c, a plus b plus c is equal to a plus b plus c. We shall now consider three integers, 12, 20 and 32. The sum of 12 and the sum of 20 and 32 is equal to 64. The sum of 12 and 20 and the sum of 32 is equal to 64. Thus we have 12 plus 20 plus 32, that is equal to 12 plus 20 plus 32. The sum of an integer and 0 is equal to the sum of 0 and the integer, which is equal to the integer itself. Let us consider an integer plus 5 and add 0 to it. The sum of 5 plus 0 is equal to 5. The sum of 0 plus 5 is equal to 5. Thus, a plus 0 is equal to 0 plus a is equal to a, where a is any integer. When a constant is added to two integers, the relation between them remains the same. Now we shall consider the integers 46 and 24. 46 is greater than 24. Add 5 to both the integers. The value changes to 51 and 29. 51 is greater than 29. Here the integer 46, which was greater than 24, remains to be greater even after a constant is added to both of them. Subtraction of integers. Vishal has 9 chocolates. He gave 4 of them to his friends. He wishes to know how many chocolates remain with him. Shall we help him? Vishal has 9 chocolates. He gives away 4 chocolates. 9 minus 4 is equal to 5. He thus has 5 chocolates with him. Thus, if a and b are two integers, then a minus b is equal to a plus minus b or a minus plus b. Examples: minus 4 minus of minus 6 is equal to minus 4 plus 6, that is equal to plus 2. Minus 3 minus of plus 6 is equal to minus 3 plus of minus 6 is equal to minus 9. Properties of subtraction. We shall list some of the properties of subtraction. They are: the difference between any two integers is also an integer. The difference between an integer and 0 is equal to an integer. If a, b and c are integers and a is greater than b, then a minus c is greater than b minus c. Take numerical values and verify the properties. Multiplication of integers. Yashu placed 4 rows of ice cream on the table, each row containing 5 ice creams each. She is eager to know the number of ice creams she has. We shall help her. The number of ice creams on the table is equal to the product of the number of rows, that is 4, and the number of ice creams in each row, that is 5. Therefore, the total number of ice creams is equal to 5 into 4, that is 20. Thus, the product of two positive integers is positive. Let us try to find what the product of two negative integers is with the following example. Consider two negative integers, minus 3 and minus 7. The product of minus 3 and minus 7 is equal to plus 21. The product of two negative integers is a positive integer. Remember, minus into minus is equal to plus. What would be the product of a positive integer and a negative integer? We shall find out this with the help of an example. Consider two integers minus 9 and plus 3. The product of minus 9 and plus 3 is equal to minus 27. From this, we understand that the product of a positive and a negative integer is always negative. Remember, minus into plus is equal to minus. What is the product of more than two integers? Consider three integers, minus 4, minus 2 and minus 6. The product of minus 4 and minus 2 is plus 8. The product of plus 8 and minus 6 is equal to minus 48. Remember, minus into minus is equal to minus. Consider four integers, minus 5, minus 3, minus 2 and minus 6. The product of minus 5 and minus 3 is plus 15. The product of plus 15 and minus 2 is equal to minus 30. Minus 30 into minus 6 is equal to plus 180. This tells us that the product of more than two integers is positive or negative according to the number of integers. If the number of negative integers is odd, then the product is a negative integer. If the number of negative integers is even, then the product is a positive integer. Properties of multiplication. For all integers a and b, the product of a and b is an integer. Let us consider the product of two integers minus 3 and plus 4. The product of minus 3 and plus 4 is equal to minus 12. Minus 12 is an integer. Therefore, the product of two integers is also an integer. That is, a into b is an integer for all integers a and b. For all integers a and b, the product of a and b is equal to the product of b and a. We shall consider integers minus 4 and minus 7. The product of minus 4 and minus 7 is equal to plus 28. the product of minus 7 and minus 4 is also equal to plus 28. This proves that the product of minus 7 and minus 4 is equal to the product of minus 4 and minus 7. Thus, a into b is equal to b into a for all integers a and b. For all integers a, b and c, the product of a and product of b and c is equal to the product of a and b and c. Consider three integers minus 2, minus 3 and plus 4. The product of minus 3 and plus 4 is equal to minus 12. The product of minus 2 and minus 12 is equal to plus 24. Now the product of minus 2 and minus 3 is equal to plus 6. The product of plus 6 and plus 4 is equal to plus 24. This proves that the product of minus 2 and product of minus 3 and plus 4 is equal to the product of minus 2 and minus 3 and plus 4. Thus, a into b into c is equal to a into b into c for all integers a, b and c. For all integers a, the product of the integer and 1 is equal to the integer itself. Consider the integer plus 7. The product of plus 7 and 1 is equal to plus 7, which is the integer itself. Therefore, a into 1 is equal to 1 into a, that is equal to a for all integers a. For all integers a, the product of the integer and 0 is equal to 0. We shall consider the integer minus 9. The product of minus 9 and 0 is equal to 0. Therefore, a into 0 is equal to 0 into a is equal to 0 for all integers a. For all integers a, b and c, the product of a and the sum of b and c is equal to the sum of the products of a and b and a and c. Let us consider the integers minus 6 plus 7 and plus 3. The sum of plus 7 and plus 3 is equal to plus 10. The product of plus 10 and minus 6 is equal to minus 60. The product of minus 6 and plus 7 is equal to minus 42. The product of minus 6 and plus 3 is equal to minus 18. The sum of minus 42 and minus 18 is equal to minus 60. Therefore, the product of minus 6 and the sum of plus 7 and plus 3 is equal to the sum of the products of minus 6 and plus 7 and minus 6 and plus 3. A into b plus c is equal to a into b plus a into c for all integers a, b and c. Similarly, we can prove that a into b minus c is equal to a into b minus a into c for all integers a, b and c. If a, b and c are integers such that a is greater than b, then the product of a and c is greater than the product of b and c if c is positive. The product of a and c is lesser than the product of b and c if c is negative. Consider integers 6, 4 and 3. 6 is greater than 4. The product of 6 and 3 is 18. The product of 4 and 3 is 12. 18 is greater than 12. Consider integers 8, minus 4 and minus 2. 8 is greater than minus 4. The product of 8 and minus 2 is equal to minus 16. The product of minus 4 and minus 2 is plus 8. Minus 16 is lesser than plus 8. Division of integers. Rajat has 64 apples with him. He wants to share it equally among 8 of his friends. Shall we find out how many apples he should give to each of his friends? The number of apples to be given to each of Rajat's friends is 64. Number of friends is 8. 64 divided by 8 is equal to 8. Therefore, each friend gets 8 apples. Note: the quotient is positive when both the divisor and the dividend have the like sign, that is either positive or negative. Consider integers -6 and -3. Divide -6 by -3. The quotient is +2. In this example, we can observe that though both the divisor and dividend are negative integers, the quotient is positive. Consider integers -27 and +3. Divide -27 by +3. The quotient is -9. This tells us when the divisor and the dividend have different signs, the quotient is negative. Properties of division. If a and b are integers, then a divided by b need not be an integer. Consider two integers, -9 and +2. Divide -9 by +2. The quotient is -4.5 and is not an integer. Thus, when two integers are divided, the resulting value need not be an integer. If a is an integer which is not equal to 0, then a by a is equal to 1. Consider the integer 5. 5 divided by 5 is equal to 1. Hence, any integer except 0 divided by itself gives 1. If a is an integer, then a divided by 1 is equal to a. Let us consider an integer 25. Divide the integer by 1. The quotient is equal to 25. Here, any integer divided by 1 gives itself the quotient. If a is a non-zero integer, then 0 divided by a is equal to 0. But a divided by 0 is not meaningful. Consider the integer 100. Divide 0 by it. The quotient is also 0. This shows that when 0 is divided by any non-zero integer, the resulting value is also 0. Note: the value of 0 divided by any integer is 0, but a number divided by 0 is not meaningful. The value of the quotient of a divided by b divided by c is not equal to a divided by the quotient of b divided by c unless c is equal to 1. Let us consider any three integers 120, 4 and 5. Divide 120 by 4. The quotient is equal to 30. Divide 30 by 5. The quotient is equal to 6. Divide 4 by 5. The quotient is equal to 0.8. 120 by 0.8 is equal to 150. We see that the two sets of divisions produce different quotients. Hence, a divided by b divided by c is not equal to b divided by c, unless c is equal to 1. If a is greater than b, then a divided by c is greater than b divided by c if c is positive. A divided by c is less than b divided by c if c is negative. Let us consider the first case. A divided by c is greater than b divided by c if c is positive. Consider integers 27, 9 and 3. 27 is greater than 9. 27 divided by 3 is equal to 9. 9 divided by 3 is equal to 3. 9 is greater than 3 since 3 is a positive integer. Now consider the second case. A divided by C is less than B divided by C if C is negative. Let us consider integers 27, 9 and minus 3. 27 is greater than 9. 27 divided by minus 3 is equal to minus 9. 9 divided by minus 3 is equal to minus 3. Minus 9 is lesser than minus 3 since minus 3 is a negative number.